Okay. Am I audible, Jason? Good. That's what I'm telling.
Yes, sir, audible.
Okay. Well, let's wait for the students to join and then we'll start. Okay. Just wait for 2 more minutes. Okay. What are the instructions we had completed in the last lecture? Can you write down the same thing in the chat box? Like what are the instructions we had discussed in the last lecture? Okay. Please write down the instructions what we had discussed in the last lecture. If you don't write, how should I know that these are the instructions we had completed? Okay, DCRM, do we completed that? Okay, that completed. What about the arithmetic? What about the arithmetic? Do we completed the arithmetic instruction? I think we had completed the add, ADC, SUB. That is completed, correct, Rajesh? Okay, what about the logical? What about the logical? No, we are not completed. Okay, good. We'll start with this logical instruction. The screen is visible, all of you? I think the date for the GTU exam has been declared. Yes or no? All the students. It's from 1st March, I think. Okay, so might be this week. After this week, might be it will be like a, what do you call it? The reading time for you. So till that, see what you can do. Okay, so we'll start on logical operations. What we'll do, we'll discuss about AND or XOR. And there's also one we call as a NOT, and NOT is nothing but a complement. The rotate and compare instructions. So these are the nothing but a logical operations we have. Well, let's suppose here we can able to use AND or XOR. Let's suppose if I want to use an AND operation, then what should I do then? If you want to implement the NAND gate, but there is no instructions for the NAND nor and XNOR. So what you will do with all that? What will you do for that? And plus not. Very good. So that is what we can discuss over here. Okay, fine. Now, what I'm doing, let's start with the first instruction. All of you knows about the AND operation. So whenever you write like A and A, in arithmetic, whenever you want to do the addition, with whom it will do the addition and where the answer will be stored after doing the addition, which register will always use in arithmetic? Which register always be used to do the addition? Yes, no, not a DR. We have so many registers A, B, C, D, E, H, L. Which register will be used to do the any arithmetic operation with any register? An answer will be stored in that particular only. No, not an HL. That will be used for DAD instruction. When you are adding a 16-bit data, I'm talking about the 8-bit data only. What is that? It will always be an accumulator. A is always be responsible for doing addition. Okay, the data what might be over here, it will always be add with an accumulator, and answer will be stored in the accumulator only, always. Okay, so here what you are doing in the logical also the same thing. We can do the ANDing operation A and A. If I write B, so it will do the ANDing operation with a B, and answer will be stored in A only, remember. Okay, the accumulator always be there for an arithmetic and the logical operation. Let's suppose consider over here is accumulator is AA, that is a 1 0 1 0 1 0 1 0, and B is 0F, so 0 0 0 0 1 1 1 1. Do the ANDing operation and write down the answer, and write down the answer what should be in the accumulator after this instruction. What should be the answer in hexadecimal? In accumulator after performing the AND operation. Simple AND operation. I think AND gate, everyone knows about the AND gate. Isha, Jay, Rutvi, Yash, Daksh. Simple AND operation cannot able to do. What should be the content in the accumulator after performing this? B9. Very good. Okay, let's check. 0A is the correct answer. Simple AND gate 1 0 0 0 0. What is the answer? 0A. How you got B9, Jaishankar? Simple AND gate operation. Really very good then. Fine. Okay. So accumulator contains a 0. Let's suppose if I write like this. A N A M. What do you mean by this M? M indicates HL. What is in the H and L? The 20 and 50. So when you combine this 20, 50, it will consider an address. So it will go to that address. The accumulator will be do the AND operation with the content of M. It's not with M, with content of M, and answer will be stored in a accumulator. So what should be the answer for here? It's a B3 and a 55. What is the answer? Write it down in the chat box. The answer, all of you. Okay, those who are joined recently, simple AND operation. What is the answer? Yeah, really don't want to write anything else. So should I just go on presenting the slide if you want? What about the other students? Okay, if Jaishankar want to give answer, let it be. Rest of the students can leave the lab. Today, the no students will get attendance. Okay, all of you can leave. Simple AND operation cannot able to perform from you. Write down the each and every students write the answer, then and only then I will present the next slide. Otherwise, be sit quietly then. Today, no students will get attendance except the Jaishankar. Okay, fine. If you want to leave the lab. Okay, the answer is 11. Okay, the 1H. So Jaishankar, you can see over here what is the AND operation will be performed over here. Same, let's suppose if I don't want to use an register or memory location, let's suppose I want to use an intermediate user defined data. Let's suppose if I write like this ANI 32H. That means this is an user defined data that will be performed AND operation with B3 and answer will be stored again in the B3 only. Okay. So let's suppose consider this ANI.
Hello, sir.
Yes.
सर 11 एंड तो इसको फिर हम चेंज नहीं करेंगे हेक्स में
हेक्स में ही है वो 11 तो यहाँ पे 55 हेक्साडेसिमल में है तो 010 0101 5. B means 1011. 3 means 0011. So that means you are doing the hexa operation only, and answer you are getting in the hexa only.
Okay.
Okay. So let's suppose you have the 32H. Now solve for this and operation with 32 with B3 and write down the answer in the chat box. Right. 32 operation will be performed with B3. You will get 32 only. આનંદ નહીં આવડે તો વાંધો નહીં, but don't write the same answer what the students are writing. Simple, don't know how to convert the hexadecimal also. Solve this. What is this? Okay. Good, Anand. તું એક જ હાચો. તું ને જયશંકર and મહેશ નાયક wrote the answer. These are Jayashankar, Rajesh Parmar. B2. How you got the B2? Don't know. And operation. Get the 33. So B3. Okay, they took the data as a 3F. So you will get a 33. For our, we got a 32. That is the correct answer. Solve for this XRAM. Okay, same as the AND operation, we have XOR operation. Write down the answer in a chat box. What is the answer? Simple. Performing an XOR operation. Yes, I need an answer in hexadecimal if you want to write. E6. See, E6 is the correct answer. Okay, the same thing, the accumulator will be updated, rest of the things will not be updated. So if I write an XRI 39H, so this is nothing but accumulator the B3 and the 39, the operation will give you 8A. So 8A will be updated over here. Same ORA. Okay, here I wrote ORA B. Perform the operation and what should be the content in the accumulator after performing the OR operation? Okay, someone wrote BA. Good. So answer is BA and that will be stored over here. Okay, simple. If you understand and operation, the understanding of OR and XOR is very simple. So here also the same thing, like here the F7, so I'm not spending the time for doing the calculations. Each and every student know how to do the OR operation. So ORAM, that means the M contains HL, so it will go to that location. What is the data? It will perform the operation with this, and answer also will be stored in accumulator only. ORI. Okay. Now coming to the logical operation, these are nothing but the operations we can able to perform the logical gates. Now here CMP. See, CMP stands for comparing the data. Now the comparing means whenever you compare the two things, you never update the other thing. Let's suppose if I'll tell you that, okay, the 5 and 6, which is the greater? So 6 is the greater. So you cannot able to replace that 5 with a 6. Okay, just you can indicate that which is the greater, which is the smaller, and which is the equal. So here there are two possibilities. Whenever you are comparing any register or any memory location data, it always be compared with accumulator only. Let's suppose first, if I have A greater than D, here I wrote D, that's why it's a D register. If you write B, it will be B only. Okay. Second, it might be possible that A is less than D. It might be possible that A must be equal to D. There are the two flags, the carry flag and the zero flag. When the zero flag will be 1, when both the values are 1 and answer in the accumulator you got it 0, at that time only the zero flag will set to 1. So in which condition 1, 2 and 3 the zero flag will set to 1? In which condition the zero flag will set to 1? Where you are getting the 0 as an answer in an accumulator. When you will get a 0 as an answer? When the numbers are greater than each, like greater than A, less than A, or might be equal to A?
Equal.
Equal to A. So when A equal to D, how you will get that? When you do the subtraction A minus D, you understand that, okay, I got 0 as an answer in an accumulator. So during that, the interval, the accumulator when it gets 0, this 0 flag indicates that you got the 1 set and this will be 0. This one indicating to the processor that, okay, now the accumulator is get 0 because the numbers what you had mentioned that is equal to the accumulator. What happens if it is A greater than D? That means answer will get in positive. There is no negative numbers will get. Okay, if it is positive, no 0 flag will set because answer will not get 0. It might get positive 1, positive 2, anything it will come. but it's not 0. So there is a no negative. That's why the zero flag, carry flag is 0, and the 0 flag is also 0. When A is less than D, that means let's suppose the D is 6 and accumulator is 5. So this is what situation. So in that duration, what happens? You will get an answer as a negative. And during that, the 0 flag will not set, but the carry flag will set to 1. Is it clear, all of you? Understand this three situation? Understand this three situation, all of you? When you compare any data with accumulator, there are the three conditions. Either the A accumulator might be greater than that number, less than that number, or equal to that number. If accumulator is greater than that number, that means how you can tell that whether the number is greater than or less than depends upon the answer you can say, Jaishankar. Let's suppose the accumulator is 6 and the register what you had mentioned is 5. So obviously A greater than 5, 6 minus 5, that means the number is positive. That means you can say that the number what is present in accumulator is greater than the number what you want to subtract. During that, none of the flags will be set. Zero flag kab set hoga? When you will get answer 0 in your accumulator. But here we are not getting 0, we are getting positive number. So that is why here none of the flag will set. When accumulator is less than the number what you want to compare, at that time the carry flag will set to 1 because answer will get in terms of negative. Okay, and the 0 flag again will not set because the number is negative, not 0. When both the numbers are equal, A is equal to B. That means if you do A minus B, obviously you will get an answer as a negative. Okay, so the 0 flag will set to 1, the answer carry flag will be 0. Clear this situation? All of you? Okay, so here what I am doing, I am putting one situation. Compare D. So A and D is given. What should be the answer? See, this value will not change. Only there will be a change in these two flags. So what is the condition of the carry flag and the 0 flag? If I write this, all of you write down the answer. What should be the value of carry flag and 0 flag after executing this equation? What should be the condition of the carry flag and 0 flag? Carry will be 1. Okay. Why? Because A is less than D. The carry will be 1. 0 flag will be 0. Okay. This is what the situation. Here it is mentioned wrong. This should be 1. Okay. So this is what. Tell me about the carry flag and the 0 flag for this CMPM. Write down the answer for CMPM. Yes. The zero flag will be set to 1. What the US said is correct. What about this CPI 30? Zero flag. Okay. Are you talking about the second one? I think. What about the third one? This one. The CPIM. Compare with immediate data 30H. Okay, so here the correct answer, because this number is greater than the 30H. So obviously none of the flag will be set. Good. Okay, now here we have one instruction. Till now we can able to do the operations on the 8-bit. Till now we don't know how to do the operation on a 1-bit operation. So what I am doing here, STC stands for, there is a no operand for this instruction. It's nothing but a set carry. Okay, it's nothing but a simple the set carry. So here the carry is 0. When you write an STC, this carry will be converted into a carry 1, and that is what we call set carry. Here, if you want to complement the carry, that means what might be the value of a carry, and if you want to complement, then you will write CMC. So this one will change to 0. Let's suppose the previously if it is 0, if you write CMC, carry will change to 1. So that is nothing but the CMC. And the last we have complement accumulator. Let's suppose the accumulator the data is 0, 0, 0, 0, 1, 1, 1, 1. Now when you write a CMA means all the values or all the bits of an accumulator will be inverted. So this is a 0, 0, 0, 0, 1, 1, 1, 1. So 0 converts into an F0. So there is only but each bit of an accumulators are converted into 1 to 0 and 0 to 1. Look at the instructions, and still if you have any doubt, let me know. Is it clear, all of you? The simple instructions are there. Is it clear? Jason, the STC stands for set the carry. That means if the one value already there in the carry, and if you write set carry, it always get an output 1 only. But in complement, if it is 1, it will convert into 0, and 0 converts into 1. That is what the difference, Jason. Clear? Okay. Now there is a instructions related to the logical operation. That means if you want to rotate right or rotate left, this instruction will be used. Let's suppose RLC. Here the RLC is rotate accumulator left. Here it should be without carry. Okay, it's without carry. So here what happens is B7, the data will go over here, so it will be B7 rotating left. Then here it will be B0, B1, B2, B3, B4, B5 and B6. So this all the bits will be shifted when this bit is shifted over here. If it is RRC, that means no carry is included, only the 8 bit will rotate. RRC means rotate right. Right means this bit will go here. So here it will be B0, B7, B6, B5, B4, B3, B2 and B1. So this is how we can able to rotate the data. Now, when you write RAL, see remember here you need to rotate accumulator left through carry. That means now the carry is been included. So how it will be like here, look at this. This is an 8 bit plus carry is always be there. Now rotate left, that means this bit will come here and the carry bit will go here instead of here in the B7. Instead of B7, now the carry flag will go here. Okay, so here it will be carry, then B0, and here it will be B6. In the carry, the bit will be B7. In the rotate right with carry, that means rotating here. Okay, the bit will go from here to here, and each bit will be shifted, and the B0 bit will go to the carry. Okay, and the B7 it will come carry. Understand the rotate operation with carry and without carry? Understand the operation with carry and without carry, all of you? Okay. Everyone knows how to do the ones complement, twos complement. Let's suppose consider there is a one data which is stored on this location. Consider this data 42. Find the ones complement of that number and the twos complement of that number. Everyone knows how to do that. First, what I need to do, invert, okay, but which instructions will be used to invert the data?
Not operation.
There is no not operation is there here.
Complement, sir.
Which complement? That means first you need to take the data into the accumulator. Then only then you can able to complement, correct? Yes or no? So how to take the data of 2300 42H data, otherwise what you can take a simple data, so then it will be easy to understand. Take 0F data into an accumulator. What is the instruction? Write it down. What is the instructions? Can able to take the data into an accumulator? Okay, the LDA, very good. So first we'll take the data as an LDA 2300. I got the data. Then I need to complement the data. The data is an accumulator, so I'll let CMA. The data is converted into a ones complement. How to convert into two's complement? How
Add
to?
one, sir.
Add one. That is the one option. What is another option? So how you will add one? What is the instruction you will use for adding one? What is the instruction you will use for add one?
Increment, sir.
Increment. Very good. Either you can able to use INR or you can able to use, if you can able to use INR also, or you can able to use ADI 01H. Okay, all of you. Is also you can able to do it. Okay, INX, that is okay. But how will do this add one, that is ADI 01H, and you will get a correct answer. So this is nothing but a converted into a two's complement. Okay. Okay. So they had converted this thing into one's complement, and this is the two's complement, and then they use SPA. Fine. So what I need to do now, you can able to complete the experiment 4, which is given in the canvas, all of you. Okay, the deadline is also been given, so that now it is easy to complete that in that experiment. So complete that now, and still if you have any doubt in any questions, I'll be here. Okay, they told in the one of the question they told the masking of bit. Let's suppose consider the data in accumulator B is EF and the content of C is F2. I'll ask you to mask higher bits, higher 4 bits. Okay, what do you mean by masking the higher 4 bits? Let's suppose consider I'm taking the data of B, that is an E 1110 1111. Which is the higher bit? Either this one is a higher bit or the second one is a higher bit. Which is the higher bit?
Second one.
Second one. Okay, so masking the second bit is what? Here, masking the second bit, that means after the answer, that means here you need to do some ending operation such that when you get an answer, this should get 000 and this bit should remain as it is. So after the masking, this data should be 0F, and here the masking, the data should be 02H. So how will do the masking? That is an important concept. Okay, that is what the concept we have to use in the experiment given in the canvas. Yes, might be after 15 the college will start. Okay, on the 15 itself. All of you.
15th, sir, March.
March, February.
February.
It will work on an online and offline mode. Those students can want to come, they can come over here in the college.
Both online and offline will be there.
Online, offline will be there.
Okay, sir.
The timetable will be said by today or tomorrow. Okay. Now complete the assignment. Okay, sorry, the net is just disconnected. So all of you, the EC students, write down the attendance.
Sir, what about the mid exam?
For this is a department level, so what I had decided, when you will come over here, we'll take the mid over here itself. Okay, the descriptive form.
So we are thinking to come in March.
Thinking in come of March.
Otherwise, they will add this hostel charge for half month. That's why.
Okay, so we'll discuss this thing in a once we'll do the meeting for the COA.
Okay, sir.
Today you just what I'm doing, I'm arranging the meeting at 3 o'clock. Okay, so
Okay,
discuss.
sir.
So 3 to 4 we'll discuss this thing about the COA. Okay, because they already took the first midsem for the students for the sixth semester. Okay, today we'll discuss. Yes, rest of the students, write it down the attendance, the EC students, and leave. We'll meet at 3 o'clock. All the students who are taking the COA subject. Okay.
Okay, sir.
Hmm. Those who wrote, they can leave.